This problem's a little bit tricky. A box contains nickels, dimes, and quarters worth $2. Find all the possibilities for the numbers of each coin if there are 3 more dimes than quarters. At first glance, you might want to say nickels plus dimes plus quarters equals $2. But then we have to account for the fact that a nickel is 5 cents, a dime is 10 cents, so we could do 0.05 nickels plus 0.10 times dimes plus 0.25 times quarters equals 2.00. But then there's another little catch in this problem. There are 3 more dimes than quarters. So if I have Q quarters, I have to use the number of quarters plus 3 for dimes. So I'm going to change this. So then I'm only going to have a problem with 2 unknowns here. Now, another thing I'm going to do is, you notice I have 2 decimal places in everything here. I could multiply this whole problem by 100 first so that I can get rid of the decimal points. I like to do that. It makes the problem easier to solve. So first I'm going to do 5n plus 10d plus 25q equals 200. That's going to be a little bit better. Boy, the red doesn't show up too nice, does it? And then the quarters and the dimes were similar in that the number of quarters and the number of dimes was 3 more than quarters. So I'm going to replace that d with a q plus 3. So now I have 5 nickels plus 10 times q plus 3 plus 25q equals $2. And that's going to be a better problem to solve to figure out how many nickels, dimes, and quarters do I have. So at first, I think I should multiply that 10 through and then add some like terms. What do you think? So let's do that. So I get 5n plus 10q plus 30 plus 25q equals 200. We're going to subtract the 30, and we're going to add the quarters together. So my new equation is going to be 5n plus 35q equals 170. And that is the equation that will give me the number of each coin if I can figure that out. So let me erase some of this stuff here. Now that we've got that part figured out. And remember, I need to find out how many nickels, how many quarters, how many dimes, right? And remember, dimes was quarters plus 3. So let's think about that in terms of the number of coins. Okay, so now that we have the equation, let's make a little chart to get all the answers in an organized fashion. So we're going to do quarters, dimes, and nickels. So here's a chart for my answers. And remember, dimes is quarters plus 3. All right, so let's start out with 0 quarters. All right, so if I put a 0 in here, 35 times 0 is 0, so that means 5n is 170. Divide by 5, and you get 34. So that means there's 34 nickels. And the dimes are quarters plus 3, so quarters is 0, so 0 plus 3 is 3. All right, now let's try a situation when I have 1 quarter. Okay, so when I have 1 quarter, 35 times 1, so 170, take away 35. 170, take away 35. 135, so now I have 5n equals 135, divide by 5, n equals 27. So, what did I say? I had 1 quarter this time, so that means dimes is quarters plus 3, so that would be 4 dimes, and 27 nickels. Now what happens? Try 2. What happens if I have 2 quarters? And again, you can do the arithmetic. The dimes is quarters plus 3, so that would be 5, right? And 13 here, if I figure it out. Then we're going to do with 3 quarters, right? How many dimes? 6. And again, I have to plug this in to solve for the n. But when you do, you come out with a 6 there. Then I'm going to do 4 quarters, right? When I do 4 quarters, how many dimes do I have? Quarters plus 3, that's 4, 5, 6, 7. Teacher can't add here, right? And I end up with no nickels that time. And then the other case you might be thinking about, well, if I have 4 quarters and 7 dimes, right? 4 quarters is $1, 7 dimes is a 70. Why couldn't I have 4 quarters and 14 nickels? That makes $1.70. You know why that's not an answer? Because the dimes is always quarters plus 3. So if I have quarters, then I have to have dimes also. So that's why the example 4 and 14 over here for nickels will not be an answer to this problem. So hopefully that helps. Okay, so here we have a digit problem. This one's a little bit tricky. The digits of a positive 2-digit integer n are interchanged to form an integer k. N is odd, and n exceeds k by 18. So at first glance you say, well, that sounds easy. I could go n is greater than k plus 18. But the tricky part is n is a 2-digit number, and so is k. So I can't use n and k to represent the digits. So the tricky part about solving this is using 2 digits here. So let n equal, and I'm going to put this in quotes, x, y. Those are 2 digits, all right? And then let k, the digits are reversed, so what do you think? yx. Now, when we talk about digit numbers, we have a part of what they look like. They also have to have a value part, because when you use them in the equation, you need to know what is the value of this 2-digit number. Well, the value of xy is really 10x plus y. And what do you think the value of yx is? 10y plus x. The reason being, let's take any 2-digit number like 25, right? The value of that number is the first digit here, or the tens digit times 10, or 20 plus 5. You learned how to do this stuff in like 4th grade, I think. So when you're doing digit problems, you have to think about what do they look like, and then what is their value. The value of this is 20 plus 5. So to finish this up, we have to put the value of n and k in this equation. So now I have 10x plus y is greater than 10y plus x plus 18. And then if you solve that by moving everything on one side and dividing by 9 in the end, you end up getting x minus y is greater than 2. I'm sure you can do the algebra there, so I'm trying to save time. Now, the other part that we have to think about, clues to the problem, if n is odd, and n is this number that looks like xy, the y digit is odd, so the choices for y, right, if the 2-digit number is odd, the choices for y would be a 1, a 3, a 5, a 7, or a 9. Now, the x, which is the first number, if we're interchanging, and basically we're interchanging numbers, we can't use 0 in either one because you can't have a number that starts with 0. You could have a number that ends in 0, but we know that it's odd, so 0 doesn't fit there either. But if I have to subtract the 2 digits and I have to have greater than 2, then the x, the largest number or the smallest number that x could be, would be 4. Because if you think of 4 minus 1 is 3, and that has to be greater than 2. I can't use 3 minus 1, right, if that's the smallest digit. So I'm trying to think of possibilities for the x and the y. So the x has to start with a 4, right? And then it could be a 5, a 6, a 7, a 8, or a 9. Do you agree with that in terms of the digits? Think about putting the digits together so that we have the 2-digit number. 41 is the first one, and I can't use 4 with any of those other numbers because when I subtract them I have to have greater than 2. So let's now go to 5. Could I use 51? Yep. Could I use 53? Nope, because when I subtract them it's not greater than 2 again. So let's go to 6. 61 works. Ooh, 63 also works. So hopefully you can finish the rest of these by checking the little formula there to get all the answers to the problem. Good luck.